So we want to start with the exam review. Let's start with question 1. We are given this table here, and then we are asked to find the marginal distribution of blood pressure level, right? So how do we find the marginal distributions of blood pressure level? So here we can see that we have two variables here. The variables are age and then blood pressure. Can we see that? It's age and then blood pressure. And we are asked to find the marginal distribution of blood pressure level. So you can see that blood pressure is here. And then 8 variables are the rows. So with blood pressure, we have low, normal, and then high. Can we see that? So to be able to do that, what I want you to do is to find the total for low. So sum across here. So you sum across the columns. So for low, 24 plus 41 plus 32. Write the total here. Is that okay? For normal, 40 plus 90 plus 98. Write the total. And then for high, 17 plus 59 plus 75, and write the total. Is that okay? So do that and tell me the total. What is the total for low? 97. Did you get 97? What is the total for normal? 228. What is the total for high? 151. So you guys should be able to confirm. One of your colleagues was able to do that for us. So low, he had 97, normal 228, and then high 151. So what is the total for all of them? So 97 plus 228 plus 151. What do you get? 476. So to find the marginal distribution of blood pressure level, first and foremost, we know we are going to do for low, normal, and then high. So for low gives you, low, we had a total of what? 97. So 97 divided by 476. What do you get? Zero 0.20. So like 20%. And then let's do for normal. So normal, we had a total of what? 228. We divide that by 476. What do you get? 0.4789, which is approximately 48%, right? And then you can do that for high. So when you look at the possible answers here, you can see C has 20 for low, 48 for normal, right? And then that is the only distinct. B is totally out because B, these are what for H. We are interested in what? Blood pressure. Is that okay? And so we see 20 for low, 48, and then you have to do the last one. If you do the last one, you're going to get 32. So then that is how to compute the marginal distribution of blood pressure level. Is that okay? you can be asked to compute the marginal distribution of H. So you use that idea to also do. So that way I'm going to sum according to the columns. That way. Now, these are the test scores. And we are asked to find the lower hinge. Lower hinge is the same as Q1 or the lower quartile. So enter these numbers in StatCrunch now. Lower hinge is the same thing as what? Q1. So enter these numbers in StatCrunch. Or StatCrunch can help us find the lower hinge easily.
Like I'll just take the first row and go down.
Yeah, just take the first row and just go down. You don't need to move to the second row because they are just 15. So I have been able to enter mine in StatCrunch. So to compute the lower hinge, so you have to know the lower hinge is the same thing as what? Q1. So to be able to get Q1, I just go to stats, I go to summary stats, and then I hit columns. I select V1 because that is where I entered my data. It's V1 here. And then I just want Q1. I want to save time. So I just select Q1. I compute, it's 57. Any questions? Okay, let's proceed. So you see 57, that is A. And then we also have these prices here for different CD players. We want to find the standard deviation. So same thing. Let's get to StatCrunch and put in those numbers. Now, one entry, you just need to make sure that you're entering the right numbers because if you don't enter the right numbers, your output would be incorrect. Is that okay? So make sure that you double check the numbers you're entering. So when you do that, I've been able to enter these numbers here. And then I just want the standard deviation. So to get the standard deviation, we go to start, summary start, columns, V1. I just want the standard deviation. So I look through and then I have the standard deviation here. I click compute, which is 97.91. So that is C. Does that make sense? Okay, let's proceed. So now we have this here. We are given this 24 randomly selected employees. And then we are asked to find the IQR and then the standard deviation. And then which is most appropriate measure of spread. So now the IQ and the standard deviation, StatCrunch would help us do that. But what is the most appropriate measure of spread? When we look at the box plot here, what can we say? Is it skewed or not? It's skewed. It's skewed to what? Is it to the left or to the right? It's skewed to the right. Is that okay? So anytime we have a skewed distribution, the best measure of spread is the IQR. Is that okay? So that we know. So the appropriate measure of spread is the IQR. So now enter these numbers in StatCrunch, compute the IQR and then the standard deviation. So let's do that. So usually for me, when I just hit on reload and everything goes off. So I've been able to enter mine. And then all you want to compute is IQR and standard deviation. So you still go to start, summary start, columns. I hit var. What do I need? I need standard deviation and then IQR. I just select those two. Is that okay? And then I hit compute. So this is IQR, this is standard deviation. So you just need to go to that and then check. So you can see the standard deviation like 769, right? And then the IQR is 715. So what is the right answer? So we can see E matches that, A also matches that, but we already said that IQR is the best measure of spread whenever we have what? Skew data. Is that okay? So we can see here IQR is 715 and the standard deviation is 769. But then we know that what IQR is the best measure of spread because whenever we have outliers or skew distributions, the IQR is able to withstand or resist those outliers. I think the printing here is it's not complete, but that is what they are trying to put across. So the answer is E. Let's get to this data here. So let's get to 5. So 5, we have this histogram. We were also given this summary statistics. And then we are asked to choose the box plot that represents this data. So to be able to do that, tell me, looking at this histogram, what can you say? It's skewed right. Can we see that? Okay. And then do you also see that you have one here? These ones are far apart from the rest of the data. So they are giving some idea that they could be outliers. Can you see that? It's skewed right, but look at these two here. They are far away from the data. Is that okay? So let's look at our box plots. So looking at our box plot, this box plot here is skewed right. This is also skewed right. Can you see that? This is skewed right. This is skewed left. This is out. This looks a bit symmetric. So we can see that we are in competition between I, and I. Is that okay? Now, what is the difference here? Here, these dots you see here are outliers. Is that okay? So here is showing 3 outliers. Here shows no outlier. Is that okay? Here shows 2 outliers. So what do you think is the right answer? Is the first one, isn't it? Because of the 2 outliers. Now, when you look at the data here, you see this one here and then this one here. Does that make sense? Good. So our answer is A. Let's get to 6. So for 6, we are told that here are the summary statistics for the size of forest fires last year. The smallest is 66 acres. This is the mean. This is the median. This is the range. This is the IQR. We have Q1, standard deviation. And then they are asking you if it costs this amount per acre to fight fires, you should find the minimum, the median, standard deviation, and then the IQR. What do you think that answer should be? Anybody wants to help us? Why?
Take the number and multiply by 1200 and multiply by 1200.
Okay. So do you guys remember when we learned what happens to the location when we multiply and those kind of stuffs? Do you remember when we are dealing with shifting and scaling? So it's the same thing. So now if you multiply by 200, what does it affect? It affects everything, isn't it? So if you multiply 200 by 66, what do you get? So you see, this is the cost. This is the cost is 200. So we are trying to what? Scale, multiply everything here by. So we know when we scale, it affects both location and then also what? Spread, isn't it? So then the correct answer is what? D. Let's get to 7. So for 7, they are saying that draw the normal model and use the 68, 95, 99.7 rule to answer the question. It's very important that you understand what they are saying. So they want you to use this rule to answer this question. Is that okay? The 68, 95, 99.7. Assuming a normal model applies, we are given that it is model. So when we have this, what does it mean? What does the 46 stands for? Anybody want to help us? The mean, right? So the mean is 46. What is the standard? What is a 3? Standard deviation. Is that okay? So you should write down the mean is 46. Standard deviation is 3. Is that okay? And so we have to draw and label the normal model. So when we look at this thing here, what does the normal model say? 68% means that it should be within 1 standard deviation. 95% rule says that it should be within 2 standard deviation. Is that okay? And 99.7 rule says it should be within 3 standard deviation. So it means that when we look at this one here, for 1 standard deviation, we know that our mean is 46. Our standard deviation is 3. So the 68 rule says that mu minus standard deviation and then mu plus standard deviation, which should give you 46 minus 3, 46 plus 3. What do we get? We get 43 and then 49, isn't it? And then let's get to the other one. For 95%, should be within 2 standard deviation, mu minus 2 standard deviation, mu plus 2 standard deviation. That should give you, if I multiply standard deviation by 2, I get 6. 46 minus 6, 46 plus 6. What do we get? 40, 52, I think. And then you should also do the same thing for the 95. The 99.7. 99.7 means within 3 standard deviation. So when we look at the possible answers here, so if I were to be you, when you look at the answers here, I would focus on, say, this is giving you the 95% interval. What is the 95% interval? The 95% interval is here. This is within 2 standard deviation, isn't it? The first one is 68. Within 1 standard deviation, this is 68%, 95%, 99.7%. Is that okay? So you can see the 95% interval. When we look through that, that answer should be what? B. Should be D, because we had 40 and then 52, isn't it? 40 and then 52. So then that is D. Let's proceed. So find the percent of standard normal found within this region. So I want you to do that. You can use your StatCrunch to do that, isn't it? So we go to StatCrunch, and then we go to Stats. We go to Calculators, and then we go to normal. I put in between here. I put 0 and then 1. And then let me put 0.7, 1.98. Can you see that? We are told standard normal. So standard normal, mean is 0, standard deviation is 1. Is that okay? Mean is 0, standard deviation is 1. And I want the percent between 0.7 and 1.98. You see, 0.7, 1.98. And that gives me 21.81%. And that answer is A. Is that okay? Any questions on that? Okay, let's proceed. So now tell me, your monthly electric bill in Dallas, is it quantitative or categorical? Why? Yeah, because it's numbers, right? It could be $50, $60, and what have you. Let's get to 10. So for 10, we have this information. So the question wants to ask you, on what percent of days was rain predicted? So when you read it, it says that here's how accurate weather forecast we hear every day. The table below compares the daily forecast with actual cities weather for a year. So when you look at this one here, so we want to know on what percent of days was rain predicted. So to be able to do that, now we are told that on what percent of days was rain predicted. So here is the same as the forecast, right? Is that okay? This is the same as the forecast or they are predicting. So here is what actually happened. Is that okay? So here they are saying on what percent of days was rain predicted. We get here. So they forecasted rain 34 plus 62. That gives you what? 96. 96 divided by the total. What is the total? The total is the 365 days. Or you could add the total here. Is that okay? So that should give you 96 divided by what? 365. Does that make sense? So 96 divided by 365 should give you 26.3. So a person's gender is, what is a person's gender? Is it quantitative or categorical? Categorical, yeah. So I want you to look at 12 and then you have this information here. Remember, and here is what percent. And you're asked which of the following is or appropriate for this data. So what they are trying to test you is that now you have these are categorical variables, isn't it? What is the best measure for you to display them? We've learned this in chapter 2. So we come here. This is I. This is II. So II here is what? Bar graphs. Is that okay? And then the third one is the pie chart. Is that okay? So what do you think is the best? Who wants to try? Why? Okay. Why not the pie chart too? Because I remember when we are dealing with chapter 2, we also displayed the pie chart for categorical variables too, isn't it? So why do you think 2 and 3? So when we look at this, before we use the pie chart is also a good measure of display for categorical variables. But to use the pie chart, remember, when we are dealing with the pie chart, we said that what? The percent here, everything here should be what? 100. Is that okay? So you have to verify if the everything here is what? This is percent. Is this 100? This is more than 100 because I could see this is 56 plus 47 plus these numbers here. This tells me that what? Here exceeds 100. And so you cannot use the pie chart. Does that make sense? So that is why we use the bar graph. Does that make sense? Any questions? Okay, let's proceed. So the next one, we are given this. We are asked to find the range. How do you find the range? Maximum minus minimum. So when you get to this, I prefer to do them by hand than to go input all this to start crunch. Does that make sense? What is the maximum number here? 99. Okay. What is the lowest number? 54. So what is 99 minus 54? 99 minus 54, 45. So you see that is B. However, you can still use start crunch. But you see that if you know the formula for the range, you save time than to go input all this and start crunch and compute that. Is that okay? So you just have to be able to decide on what to do. Now we have this data here. We want to find the inter-hinge range. The inter-hinge range is the same as the interquartile range. Is that okay? The inter-hinge range is the same as the what? Interquartile range. Is that okay? So for that, interquartile range is Q3 minus Q1. So for that, you could use start crunch to be able to what? Compute that. Is that okay? So let's get to start crunch and then input these numbers there. So I've been able to enter mine. I just want the interquartile range. I go to start, summary start columns. I hit this one. I just want IQR. I just click on that one and then I compute. And I get 29 for that. So 29, and then that is D.
What did you say was the lower hinge again?
It's Q1.
Q1.
Yeah. So interhinge is IQR. Is that okay? Lower hinge is Q1. Upper hinge Q3. Is that okay? So we are given this, and then we are told that we are given the mean and then the standard deviation. And then we are told how many standard deviations from the mean is a score of 91. Is that okay? So what they want you to do is, so let's try to compute the z-score. Is that okay? So compute the z-score. How do we compute the z-score? We know that the z-score is given as so here our x is 91. What is the mean? 51. What is the standard deviation? 11. What do you get?
3.64.
3.64. Is it positive or negative? It's positive. Because it is positive, it is what? Above the mean. Is that okay? So you can see about 3.64 above the mean. Can you see that? If it is negative, it is this standard deviations below the mean. Is that okay? You could go look at those slides when we are dealing with the V. And then let's get to 16. So for 16, we are told a standard normal model. We should find z greater than 0.59. So standard normal, 0, 1, greater than 0.59 here. I get 27.7, almost 76%. Can you see that? We are told standard normal. So I count standard normal means 0, 1. We are asked to compute z greater than 0.59. So then you get that. And that should give you B. Let's get to 17. So for 17, we are told that based on the normal distribution, so the mean is 57, standard deviation is 8. How many inches of snow would represent the 75th percentile? So let's try to do that. So we still need to use StatCrunch. So we go on StatCrunch here. Here, it's not standard normal. We are given the mean. The mean to be 57. Standard deviation to be 8. And I remember telling you that anytime you ask to find the percentile of something, here has to always be less than. Is that okay? Less than or equal to. And then let's put that number here. 75th percentile, 0.75. Is that okay? And then let's hit compute. So you see that is like 62.4 inches. I show you again. This is our problem. We have a specified mean and standard deviation. We are just asked to find a 75th percentile. I go on StatCrunch. I put in the mean and then the standard deviation I was given. Is that okay? So to find the 75th percentile, I put in 75 here and I make sure that here is what? Less than or equal to. Is that okay? And then I hit compute and that gives you the 75th percentile. Let's get to 18. So 18, you should be able to do 18. So you see Z, or you've also been told in the problem, standard normal. Is that okay? So Z less than 1.13. So try to do that. So you see standard normal, mean 0, standard deviation 1. And then Z less than 1.13. I put in a 1.13 here. I hit compute. I got 87.08. So that is C.
So using like the same data set, first data set for all the, for this one. Like, does it take the numbers you have on variable one column, is it taking those into account for this, or is it?
No. Like the standard normal, it's
Oh, okay,
separate.
that's what I was wondering, that
Yeah.
it was basing it off those.
The standard normal is separate. It doesn't take the data here. Is that okay? Let's get to 19. So we are given this summary statistics, the lower score, mean, median, range, IQR, and we are told that the score went up by 7 stroke. So it's the same thing. So here they are trying to, we learned that so the score went up by 7 stroke. That means that the score increased by 7. That means plus 7. Is that okay? So when we add or subtract, we know that the measure of skill doesn't change. Do we remember when we are dealing with the Excel? So the measure of skill doesn't change, but measure of location would increase by this. So now when you look at this, what do you think would be your right answer? So now what is the measure of skill here? So the measure of skill here, you can see range, standard deviation, IQR. Is that okay? So when you look at this one here, you just have to be able to, and then you know that the minimum would increase by what? 7. Is that okay?
Stay the same. By 7 stroke.
So the range, there are measures of spread. And we learned last week that when we add or subtract, when you look at the Excel sheet we did last time, you see when you add or subtract, only measures of location that changes by that, but the measures of scale doesn't change. And then the range is a measure of what scale. So you see that it doesn't change. So it's still 97, 94, you see. So even that alone should also help you see the correct answer. And then you see standard deviation also doesn't change. You see it's also 10. Change, yeah. Standard deviations don't change.
But you have 7 all the other.
Yeah, the 7 would, it's so lowest, they are all measures of location. So
Okay.
those ones will change. Yeah. So that should be your, we'll continue on this on Wednesday.